Hi, welcome to the call. So we got some more people joining us. I'm going to go ahead and start recording.
Conference recording started.
Several other people just joined us. Okay, if you're just joining us right now, go ahead and mute out your phone. Today is November 10th, 2014. We're at 6 o'clock Pacific time. This is Aaron Murakami, and I'm sitting here with Peter Lindemann. And the purpose of this call is basically a Q&A call for everybody who anybody who's on the call. And if you're on this call, you receive notice because you have the beginners, intermediate, or the advanced books, or a combination of all of them. And you might have some questions, and we'll be happy to answer those. There was somebody, two different people emailed me a couple questions that weren't able to make it to the call.
And I got a couple here too.
And you have a couple. And
Yeah.
so before we open up for questions on the call, we can cover these first. And then, but besides that, Peter, are there any announcements you want to make? Or,
Yeah, I would like to just start and say, first of all, thank you for your interest in this topic. It's taken us 2 years to get all 3 of these books out. And so thank you for your patience. Obviously, these books didn't write themselves in a quick flash. We realize that especially this advanced book has been anticipated for about a year at this point. And so thank you so much for your patience. Hopefully, it has lived up to your expectations and has given you, the final secrets really of John Bedini's technology. I got into the idea of the research into the idea of building a self-running electromechanical machine back in the early 80s like John did. And by 1983, we knew that a regenerative motor, in other words, an electric motor that would produce mechanical energy and give you some of its electricity back, that driving a low-drag generator was the right combination of building any level of self-running electromechanical machine. And it's been my my goal to figure out how to publish the design of something like this for 30 years. And so it was really very, very fortuitous that I was able to do that while highlighting the work of John Bedini, who was literally decades ahead of all of us in this pursuit. Though we knew what the combination was, we didn't have the equipment that would do it. John has had it for 30 years, and now we've been able to actually explain to you how the machines worked, every aspect of them. So this is a real culmination of an awful lot of work. 30 years on my part, 15 years on Aaron's part, 40 years on John's part, thank you for your interest. Your interest and your support of these projects has made it possible to get you these books. Really, this last book we started on it in May, and I spent the last 10 weeks every single day, every waking hour, working on finishing it. And if something wasn't paying my bills, I couldn't do it. So you're the people who have made it possible to bring this information out. And thank you all for your support and for your participation in this event. So the other thing I want to say is that if you have any general questions, we'll field those pretty straightforward. No question is too simple or too newbie. Everybody starts at the beginning in their lives. We weren't born with a owner's manual or anything else. We're all learning, all this stuff on our own. And so the only dumb questions are the ones not asked. So the purpose of this Q&A session is for you to ask anything that you need to move your project forward. Yeah, let's go through some of these.
Ones that were mailed in first,
Exactly.
and then we'll open up.
Sure.
Okay. let's see, okay, and these may be, we may not necessarily cover things from the beginner to intermediate to advanced. It might just kind of be a random
Yeah, it's going to jump around.
kind of thing. So, okay, so on a multi-filler coil, there are many transistors, and there are power wire coils. Matching transistors is a big step into tuning the machine, right? So am I right in the assumption that if I had one transistor that could handle the amperage of all the power wire, it would be better because it would really switch all the power coils at the same time?
Yeah, that's true. And in fact, the very first machines, obviously the machine that was built by Shawnee Bauman, that was a one-wire, one-transistor machine, and that's exactly correct. If you had big industrial transistors that could switch, 50, 80 amps cleanly at high speed, then the answer to that question is yes. The issue becomes to make a project like this affordable to people, we needed to use commercially available parts. And John's selection of audio transistors that had a switching speed in the 16 megahertz range takes it out of the league of big industrial transistors that are just used really more as switches rather than as amplifiers. So the idea of using multi-windings and multi-transistors was really so that we could get more power through the system and get the transistors to share the power and get them to share it equally and exactly on time. And so that's the reason for all of this stuff. It's absolutely true. You can demonstrate these phenomena with a single winding, single transistor, and that's been done for decades. But the reason for showing the higher level of complexity was to start showing you methodologies of getting the power up. So that's the answer to that question.
Okay. Second question here is about transistors. You recommend the MJL21194 NPN transistor, which can handle 16 amps and 400 volts with a gain of 25 HFE. Mm-hmm. In your opinion, would it be beneficial to put another high-gain transistor in front of the MJL in a Darlington configuration, like a 2N2222, which has a gain of 100, or a TIP120 with a gain of 1000? Can this speed up the switching?
Not really. Actually, Darlington arrangements slow down the switching. And the purpose of that particular transistor has to do, again, with its, not so much with its gain as with its switching speed. It's very important that all the transistors come on at the same time, but most importantly that they all turn off at the same time. That's when that big radiant spike is going to be generated, and you want all of those radiant spikes to be generated at exactly, literally within the same microsecond, okay? So the question is interesting, but gain on these devices isn't the issue as much as switching speed.
Okay, and the last question from this person is, if one is interested only in rejuvenating and charging batteries, could it get rid of the wheel and trigger the coil at about 20 to 200 hertz using a 555 timer? My understanding is that the flyback voltage would be the same if the on time is adjusted so that the core is saturated the same as with a trigger coil, right?
That is absolutely correct. Yeah, you don't need the wheel. If you're not interested in getting the excess energy from the wheel, then the answer to that question is yes. That's all there is to it. Yes, you can do it that way.
Yeah, and just by increasing the resistance on the base, you can just put it in a self-oscillating mode, and that's kind of at least the bare bones, solid state.
There's been a number of circuits on the internet that demonstrate these self-oscillating circuits. One of them is called the Joule Thief, and John has also published two separate circuits. One of them is called the self-oscillator, and the other is called the forced oscillator. and they have slightly different uses and benefits. But any of those types of things that turn the transistor into a relaxation oscillator mode, where turning it on sets up the conditions to turn it off shortly thereafter. Any of those types of systems work fine.
Yeah, and in energeticforum.com, there's a couple old threads discussing some of these solid state SG type circuits, and there's different variations in there that you can look at.
Yeah. Marty basically is asking that in the first book, basically it shows how to build the machine in a certain way. And then in the intermediate book, it shows how to fine-tune things and put the potentiometer back in to fine-tune the the resistors. And so he's asking, this brings me to the question regarding fundamental differences in instructions between the intermediate and the advanced book. In the intermediate book, on page 13, the fine-tuning calls for a 1K potentiometer and 7 matched 100 ohm resistors. But in the advanced book, we show that we leave the 470 ohm resistors in there, and with a variable resistor, we temporarily find the best spot. So he's asking which method is better. And the answer to that is that neither is particularly better. What replacing the 470 ohm resistors with 100 ohm resistors does is it gives you options to find a fine-tuning position below 470 ohms, okay? And what we did with the machine that we have here is that I was prepared to take all of the 740 or the 470 ohm resistors off this board, but decided that I wonder if I can get away with finding a fine-tuning position slightly above that and save myself the hassle. And that's what I was able to do. And we were also able to adjust the height of the wheel above the coil, which also changes how the strength of the trigger signal. So there's a number of things you can do, but the idea of replacing the 470s with 100s is to give you more options. But as you can see from what we did in the advanced book, it may not be necessary, and we got away with it on this model. So that's the answer to that one. Then Marty asks about the difference in numbers of magnets on the wheel. In the beginner's book, there was 21 magnets. Then we switched here to 18 magnets. The number of magnets on the wheel has a number of specific effects. And for those of you who have built these things, you may have noticed that the more magnets you have on the wheel, the slower the wheel goes. And that has to do with, there's a Lenz law rise time in the coil as far as how quickly the current level will rise to the point of shutting the circuit off. And so the more magnets you have on the wheel, the less time it has to reach the maximum point in that Lenz law rise time arrangement. So as counterintuitively as it is, the more magnets you have on the wheel, the slower the wheel goes. And the fewer magnets you have on the wheel, the faster it will go up to a certain point, of course. So there's a sweet spot with that. We switched to 18 magnets on the wheel for the advanced motor for a number of reasons. One, we wanted to get even spacing because we wanted the generator coil to operate in a specific fashion. And so there was 36 spokes on this wheel, and putting a magnet at every other spoke was a fairly easy way of getting a very uniform magnet placement. And so there's nothing magical about 21 magnets, 18 magnets, any of those types of things. Any number of magnets on the wheel in that range from 16 to 21 will make the wheel run well, okay?
For a single coil.
For a single coil, exactly. Now, as If you remember some of the big 10 coil machines and everything, then critical spacing becomes much more important. So again, at that point, then the placement of the magnets and the placement of the coils must be critically looked at. So again, we're just looking at a single coil and multi magnets on a single wheel. So that's Marty's second question. The last one has to do with that on the advanced circuit, we just show the capacitor being discharged with a switch S, and he's saying that that is John's comparator circuit, which it is on our model. And is there a best version of a circuit that he can build that doesn't cost $500? And the answer to that is yes, and that was actually given in the intermediate book. At the end of the section on capacitor discharge, there is a circuit with parts list and everything else that will allow you to do that. So
That's towards the end of the intermediate book.
towards the end of the intermediate book. So so that's where that information is. So that handles Marty's, I think.
Can I configure my Energizer to run in common ground mode if I don't have a capacitor discharge aspect to my circuit? Just run a wire through a 600A 100 diode from negative of charge battery to negative of run battery?
Okay. Yeah, you need two diodes for the generator mode. You can run it directly to the battery. You don't need to use capacitor discharge for that. In fact, both Aaron and I have seen John do that. So yes, but you do need two diodes. So everything on the circuit and on the advanced book that shows, and you can just eliminate the capacitor discharge. We also found from running some experiments here that those 6A100 diodes were pretty sluggish, and in a number.
And that's probably what he says. 600A.
Yeah. I know. It's a 6A100.
Yeah, 6 amp, 1000 volt.
Yeah, we found those to be pretty sluggish, and there are definitely better diodes that work than that. So, and especially if you're not having to handle a big surge from a capacitor discharge, you've already got the diodes on the circuit board that you're collecting everything from anyway. So yeah, anything, play around, try different diodes, and see which gives you the best gain, the best return.
Per the advanced book, is anything critical with respect to placement of the generator coil with respect to timing? Should the magnets be directly over only one of the coils at any given moment in the rotation, or does it really matter? I see in the photo that it looks like the magnet of the wheel is directly over the generator coil, but not over the other coil.
Yeah, that's the way we set it up. We wanted to have them out of alignment with each other. Obviously, if you're going to build up a full-size Energizer with multiple coils, then there's bound to be some overlap at some point. And if you're running the motor section independently of the Energizer section, whether they're on the same wheel or not, in the end, it's not going to make any difference, because electrically they won't be talking to each other, even though there may be overlap from mechanical issues between the two sections. In other words, when the motor's creating mechanical force forward, and when the generator is producing an output pulse, none of those things are really critically dependent on each other. In fact, both of those things are completely independent of each other. And the more of a flywheel you have on the system, the less it makes any difference at all.
And then just one final question, then we'll go ahead and open it up.
Sure.
Okay, and lastly, on a well-tuned Energizer, what is the expected good performance in terms of how long the run battery can support the machine compared to how many batteries can be charged?
Again, that's going to be, there's a lot of variables there, and that's why we've spent, something on the order of 400 pages describing all these things. The section on batteries in the first book, the section on the benefit of how quickly batteries move to the topping event, which is described in the intermediate book. All of these things relate back to the answer to that question. And so there is no specific answer.
Get the highest speed for the lowest draw for one.
Yeah, you can get, yeah, I mean, and then as John always said, let it run. Keep it going. If you're switching the batteries from front to back, once or twice a day, say every 12 hours or something like that, and just keep doing that day after day after day, you're likely to get the thing to run for an insanely long period of time. If you have more batteries on the back end, and you're running a capacitor discharge arrangement where the entire block of batteries is getting this huge surge of current, multiple times a second, what happens is that the whole block eventually kind of comes up to a sense of fully charged, and then when you just take one of them and move it to the front and the discharged battery on the front, move it and reconnect it with four fully charged batteries, that's when you really start seeing that the whole thing is just going to just keep going and going and going. And
John's done that on multiple machines.
John's done that on multiple machines, and all of these are little tricks that can keep the machine running, an intolerably long period of time. And then, as you add, a full-sized energizer to it, at that point you can start charging a whole bunch of extra batteries as well. So that covers the questions that we've had that emailed in, so let's.
Okay.
Anybody got a question out there?
Okay, so there's a couple people that have questions here. Okay, if the last 3 digits of your phone number is 461, go ahead and ask your question.
Hi there, yeah, it's Joe from Ontario. My first question is, if I have, say, 7 matched MJLs at 1% error between those matched, can I assume that they would all be turning off within the same microsecond?
Not necessarily, but they're going to be, pretty darn close, and you'll see a benefit over the use of random, 7 random transistors. Without oscilloscope.
So I haven't done any matching yet. I'm going to be, and what I'm finding is when I'm running them, some transistors are getting hotter than others.
Yeah.
Because I have them heat sinks, but they're separate heat sinks, and some of them are getting hotter than others. So they must be doing more of the work, I would assume.
You're correct about that. Exactly. So the machine is telling you, what the imbalances are, and if you want to, you can go to Teslagenics and just buy a handful of matched transistors, pretty much for the price of the transistors from anywhere else, and yeah. So I mean, don't spend a lot of time doing things unless you want to learn the whole process. I mean, we gave the directions for the transistor tester in the intermediate book. So you can do it, if you want to learn all that. But if you just want to get moving and get to a working machine, there's all sorts of these shortcuts that are available to you.
Okay, awesome. That's great. Are you using matched diodes on that demo machine? I know you're using matched transistors and base resistors, but are the diodes as well?
No. And the reason for that is that they may trigger at maybe a couple volts difference as far as overcoming their reverse blockage mode, but the rise times are so insanely fast coming out of the inductor that it doesn't really matter. John.
Yeah, I didn't think about that. You're right.
Yeah, I mean, the rise times of the voltage on that is just, it's trying to rise, thousands of volts, per millisecond. So, if the diodes are triggering at 3 or 4 volts difference, nobody's going to notice.
Yeah, you're right.
Okay,
Yeah,
so
you're right.
so and this goes back to the fact that because I worked with John every day for over a year and a half in 2004 and 2005, and the question was constantly asked, are you matching diodes? And he just said, no, it doesn't matter.
All right.
Okay,
Well, that's good.
that's what we put in the book. And now you can get the idea of why it doesn't matter.
Exactly. I have a couple more, if that's okay, or if
Sure.
not, that's cool.
Yeah, go for
Yeah,
it.
go for it.
Okay, so I've heard a lot of talk about the radiant charge battery and whether it can or cannot be used on the front end of a Bedini wheel. And you were talking there about how John says just let it run. So I would have to assume that you can do that. But I do remember, I don't know if it was in DVD 37 on the energy from the vacuum or not, but he did say that. He said something to the effect of it will run itself down if you switch them over. So I'm still quite confused whether or not it's actually possible.
Okay. I tried to cover this issue in the intermediate book. Okay. And what I will say is this, is that of all the machines I ever saw John, build and get running in the fully self-running mode, every one of them was a capacitor discharge. Okay?
Okay.
The
Yeah,
ones that worked the best were, really big capacitors being dropped across a mechanical contactor. And we're talking silver
Right.
brushes on a copper bar, okay?
Hundreds
Right.
of thousands of microfarads.
Right, yeah. 300,000 microfarads charged to 15 volts, dropping that onto a, so that it would rise about 3 volts above the battery, okay?
Yeah.
And that machine would run and run and run and run and run and run, okay? And it was discharging the capacitor about once a second. And so that's a positive, positive energy to positive energy, okay?
Right. Yeah.
And, I've seen other capacitor discharge systems run as well. And by the way, that device had the worst possible mechanical front end that you can think of. It had a forced, it was running in forced repulsion mode using a Bedini coil switch, which uses more energy than any other system, producing less return and less mechanical energy than anything else. And John got that to self-run. So anybody who says that none of this stuff works, John has gotten the absolute worst set of conditions to work.
Yeah, no, I don't doubt that it works. I was just, that makes a lot of sense, because that way, if you're pulse charging the battery, you're not giving it that radiant spike, which might confuse it.
Exactly. So the energy coming into the battery, was converted back to current surges, essentially.
Yeah.
Yeah.
Okay. Awesome. All right, that's good. This has to do with the generator coil in a way.
Okay.
John's 10-coiler machine, I noticed, if you look at the pictures on the back, he has some kind of generator coil set up. Am I wrong?
Are you talking about the big Ferris wheel, or are you talking about just a 10-coiler?
Well, that one too had it.
Well, no, that's a real different machine. Are you talking about just the
anyway, the 10-coiler, or even the 30-coiler for that matter.
Okay, well, the 30 coilers.
This last conference, it was one before that, I think.
Yeah.
Where I looked on the back, and I wasn't there, but I saw it on some YouTube videos, and it looked like there was some kind of generator coil set up on the back, separate from the coils that were around the circular wheel
Okay.
portion.
I'm gonna answer this in a couple of parts. Okay. The original 10-coiler was a machine that John and I built in 2004. Okay, all 10 coils were powered coils, and that thing could charge. That thing had 4 transistors per coil, each one of them drawing about 1/4 of an amp. So each coil was drawing 1 ampere. So 10 coils. It was a 10 ampere 24 volt machine, 240 watts input. Okay. The output of that was being used to charge that huge set of telephone, cell tower batteries, which were 24 volts at 1600 amp hours. Okay, that's what those were. Each one of those 2-volt cells weighed 300 pounds. Okay, you needed a forklift just to move one. Okay.
Yeah, no, I know. I'm in telecom. I know.
Okay, so these were 16. This is 1600 amp hours at 24 volts. Okay. Now during one set of tests, we flattened that set of batteries down to like 15 volts or something. 24 volt system. In other words, we had taken 99% of the 1600 amp hours out of it. 99%. Okay. And so when we decided that the experiment wasn't working and the batteries had flattened, both the big round ones and the big square ones were both flattened because one was running the machine and the other was supposedly being charged but not, and so on, and it just was terrible. So what I did was I set up a smaller set of batteries that was also set up at 24 volts and just put a variable supply on it that would just put 10 amps at 25 volts onto that smaller battery pack and ran the machine and put everything coming out of the machine back onto those batteries. And they were filled to maximum. In other words, the voltage on the battery rose to 31 volts and every cell was boiling in 30 hours.
Wow.
Okay? At 10 amps. 10 amps for 30 hours is 300 amp hours.
Wow.
Filled the 1600 amp hour batteries to boiling at 31 volts.
So were all those transistors and all those were all matched too, right, for that whole machine?
I don't think so. I don't. These were the early days of the multi, transistor machines. We blew up a lot of transistors on that machine, getting it able to run it all. And
I have on a smaller scale too.
yeah.
Wow.
Okay. But all I'm saying is that the reason John has, we just put out the complete plan on how to build a low drag generator, which was inherent in John's original book, from 1984. And the question is, why hasn't anybody picked up on this? And the answer is, and I try and cover this in the last chapter of the advanced book, is that John saw so much higher gains just from the radiant energy effects that having a low drag generator seemed irrelevant to him.
Right.
Okay? This is one of the things that has been so thoroughly misunderstood by most people. Why has John done what he has done? And when you look at that one particular situation where we topped out that 1600 amp hour battery that was flattened. With 300 amp hours in, gave us a full-blown 1600 amp hour storage. That's a 5-to-1 gain right there. So, and that was being,
radiant charge?
that was pure radiant straight to the batteries. There was no cap dump in that system. We didn't have a cap dump system that could handle anything like that at that point.
Yeah, that makes sense.
Yeah, because the internal impedance of those batteries was so low. I think with 12 of those batteries in series to make the 24 volts, I think the total measured resistance of that battery bank was 3,000th of an ohm.
Wow.
So the impedance of that was so low it was insane.
Then, the lower the resistance, therefore the better your cap dump will work on them?
Better the cap dump, and also the higher, the more the radiant will work on it. Yeah, when you start lowering the impedance of these systems, the energy factor goes way up.
Okay, good, because I have about six 70 amp hour gel cells that that I got. So I'm going to be working with those, so that will be good. So I could put all 6 of those in parallel and put a cap dump on those, and that would be probably a pretty good situation.
Well, personally, I would. I'm going to tell you that it's going to be another learning situation for you. Okay, gel cells are completely unforgiving. When you try and top the charge, okay, because there's no place for the off-gassing to go. Any moisture that comes out of the gel electrolyte is lost, and you're moving towards the gel not working anymore. So the gel battery is a fake solution that was developed by people who wanted to sell you batteries.
Oh, really?
Okay, yeah, it's just about creating a situation where they sell you a safety argument. In other words, if the battery tips over, nothing's going to leak. Okay, and that's the feature that you bought. Okay, but if you've got a battery that you're not going to tip over anyway, then why would you buy a battery that is going to be limited to maybe 500 charge and discharge cycles before the electrolyte dries out?
So if I'm taking these gel cells to 15 volts,
You're going to only do that if you can do that 100 times, you're lucky. You'll never do it. You can't top those batteries at 15.
oh,
Just bring them up to 14.8 max.
Yeah, 14.8, 14.7. The thing is that the chemistry isn't finished, but if you try and finish the chemistry, you're going to dry out the electrolyte, and that's the trade-off. That just isn't the battery to use.
A joke.
That's just not the battery to use.
Wow, I didn't know that. Good thing I got them for free.
Perfect price. Perfect price.
So
Yeah.
hey, there is one thing that probably should be mentioned. Okay, so and I don't know how much it's been discussed, but for example, those cell phone tower batteries have such low impedance, and you see, these gains that you don't see, with higher impedance. Do you want to mention maybe just a little bit about the possibility of people might be seeing interesting things with like lithium iron phosphate batteries?
Oh yeah.
Okay.
Yeah, here's the other deal. Don't forget, the wire on that big 10 coiler, the wire coming out of it was those big copper bars coming out of the machine, and that went directly to a terminal junction, and from there 2-watt wire went to the batteries. Okay? In other words, it was insanely low impedance all the way through. Okay? Now I've had a number of conversations with John about the importance of impedance on these things, and the lower the impedance, the better, always. The more you can get the system to drive into a low impedance situation from the wire to the batteries, everything in between, the better it works. Okay? Now, what we haven't ever discussed, it's not in writing, but more people have gotten these systems to run themselves using the brand new lithium iron phosphate battery. Okay? It's an extremely low impedance battery. It is extremely forgiving under partial charging conditions. Okay? You don't have to top it every time for it to continue to behave well. And we have, both Aaron and I have spoken to a number of people who have gotten their systems to walk 2 lithium iron phosphate batteries right up, using no extra batteries, no special other things, dumping the radiant charges right into the battery. And when I finally asked John about it, the bottom line is this: more people have gotten them to run with the lithium iron phosphate than with lead.
Wow.
Okay? The reason is it's a really low impedance battery.
And the ions don't weigh anything.
And the ions are lithium instead of lead. The amount of inertial push you have to put into the battery to get the ions to move is nothing compared to lead.
They just blow on them and they...
Blow on them and they start moving. And see, this goes back to what I was talking about in the intermediate book, where we're talking about the inertial properties of electricity. Okay? So
a cap dump would work wicked for a lithium iron phosphate battery.
right. Well, anything works with it, yes. But don't mistaken this for a lithium ion battery.
Which are normally cobalt.
Right. Don't use that battery. We're talking about the lithium iron phosphate battery. Okay? So don't be confused about that. And if you blow up your house and burn your place down using lithium ion batteries, don't blame us, because that's not the battery to use. That's a dangerous battery. The lithium iron phosphate battery is probably the safest, least toxic, most forgiving battery that's ever been made. It may be the best battery that's ever been made available commercially. And it works really well in these systems.
You have about 14% less capacity than the typical lithium ions that are in computer supplies, cell phones, and all that.
That's power-weight ratio.
Yeah, but they're safe, non-toxic, they're non-flammable,
Non-spillable,
it's
right?
complete dry cell,
Yeah.
and
Anyway,
so-
you didn't hear that from us. It's a wild rumor.
yeah, we have a friend here in town that we're not going to mention
Maybe I'll
his
just
name.
leave one more question.
Okay, go ahead.
My question is, say with the cap dump and you're trying to lower the impedance from the output of that FET, which is just some small little pin, through the cable to the battery, and it just seems like the impedance of that small little pin from that MOSFET, it would be pretty high. It's just a small little pin, and then you connect that to a big wire, but you still have to go through the small pin to get to the big wire. You know what I mean?
Yes, you do.
So-
But the point is that pin has a finite length.
Yeah.
Okay? Don't underestimate the fact that at these frequencies, if your cap, starts discharging in the first microsecond, every inch of wire is an inductance.
Yeah.
Don't lose track of that. Going directly from that pin to a large wire, well, just run some tests. Run a number 30 wire from there to the battery, and run a number 8 wire from there to the battery, and see which works better.
Yeah.
And don't call me in the morning. You know which is going to work better.
Yeah, well, Tom C has already been all over me for that, one of my videos, but yeah, that's definitely what I'm going to do. And I guess it makes sense you say at these frequencies, and when I think a lot of people think about frequencies, they think about, okay, some sine wave at 1 megahertz, but it's not necessarily like that. It's a frequency in terms of this pulse is happening within a megahertz wavelength.
Right.
You know what I mean?
Yeah. We're talking about the rise time, moving from the zero current moving condition to the current moving condition. What is the transition period? And those transition periods are very short.
Transition time, absolutely.
That's what it's
Okay,
about.
Well, that's all for now. Thank you guys very much. Thank you, Aaron and Peter, for all the work you guys do to get this all together, put together all these calls. I really appreciate it, and thanks very much.
Great.
Okay, let's see. Somebody else has their hand raised here. If the last 3 digits of your phone number is 399, you should be unmuted now. Go ahead and introduce yourself. And
Yeah, this is Benjamin. I'm from Chicago.
Hey, Benjamin, thanks so much for coming.
Yeah, thanks for hosting this. It's a nice time. So I'll just start off right away. Pretty much what I've read the intermediate manual. Can you still hear me?
Yeah.
Okay, it said my hand was low. Oh, yeah. So pretty much I initially went through, I had all the matched 100 ohms at each matched transistor that I bought from you guys.
Okay.
And I had like the pot and everything set up, and when I went to, the first time I tried running it, I couldn't get the wheel to maintain its spinning. And I found like I turned down the pot all the way down, and it worked a little bit better. And so now I shorted all those
100 ohm resistors, and I just put in a 8 ohm resistor right at the beginning of it. Now the wheel actually can maintain it and take up the energy and keep spinning.
Okay,
the whole
so
time.
let me ask you a question. What's the air gap between your magnet and your coil?
You know, it's at least an eighth of an inch, I'd say.
Okay,
So
well,
it's not terribly far apart,
we started.
but it's on the closer side.
Okay, the beginner's book said an eighth of an inch. Okay,
Yeah.
because that's what John told us to put in the book. Okay, in other words, these were dimensions to get people to start. Okay, I think what you'll find is that if you open the gap up, this machine that we're running here in the advanced mode, the gap between the magnet and the coil is 3/8 of an inch.
You said 3/4?
3/8. In other words, three times larger gap than what was specified in the beginner's book. It's very counterintuitive. A lot of this stuff, the machine does exactly the opposite of what you would expect.
Yeah, binds up if it's too close.
Right.
You know, if I would have used the 470, like I wonder if it's in terms of when all of those bases are being activated, if it's just naturally a lower resistance that needs or like more current.
See, the thing is that if you're running like 8 ohms, you're slamming those transistors on. You're burning way too much current. John used to tell me that if it was drawing more than a quarter, 200 milliamps, he didn't want to talk about it.
Yeah, I mean, those resistors were heating up, and
Exactly.
making sure that the transistors didn't heat up and
Well, you
stay
can't-
for a little while.
Yeah, so that's not the window we're looking for at all.
Oh,
Okay?
okay.
So move the coil down away from the wheel, and put in bigger resistors and start over and find a window. And you may have to spin the wheel a bit to get the the triggering started. These things don't usually you can't just flick it a little bit and get it to go when it's running in the really efficient mode. You've got to get the wheel turning maybe 20 or 30 RPM before it really has enough trigger generated, to start firing the transistors.
Nice. And if I find that doesn't actually end up working, I mean, would it be worth buying a new set of matched transistors? Because in fact, I actually tried 2 of them because I had this experience of overheating them.
Yeah.
Overheating like when I was soldering.
Yeah, if you actually had a couple transistors blow while the system was running, yeah, you may want to just replace all the transistors, because what happens is that if the minute a few of them blow, then the other ones pick up the load and all sorts of other things start happening, and the heat, the kind of damage that happens with these overheating situations, it still may seem like it's working, but its gain and its other characteristics can become more sluggish. You may want to just start over with all new transistors and put in some 470s just for starters, and then play around with the height of the wheel above the coil until you can get it to run.
And then would you recommend like using some other method apart from soldering, like the?
No. You've got to. You can start with everything just being tossed together, but I can tell you when Aaron and I built this unit here, we had the whole thing just clip leaded together, and once we knew we had the circuit all set up right, and we were getting some interesting but kind of odd results. And one afternoon I just said, Aaron, go home. I'm going to put the big wire in, and it's just going to take me a while to just replace. And after that, the whole thing just took off like a banshee. gained 100 RPM and drew less, and was charging the back battery way better. I mean, it just by cleaning up all those impedance issues, the machine just started working so much differently. And so once you know you've got the circuit right,
8 wire is good. Going to the battery terminals.
yeah, we're using number 12 on this.
Okay.
But I mean, it's a 1.4 amp machine, and we're using number 12.
Yep.
So that's what it's about. And actually, this thing would probably charge the back battery twice as good if I put number 4 wire directly from the capacitor to the battery. Instead, we've got it going through meters and a bunch of other junk just to show demonstration. But right now, even with the meters and the amp meter shunt and everything else, it's still putting 78 amp impulses onto the battery. If I just went straight from the capacitor discharge circuit directly to the battery with like number 4 wire, it'd probably be 150 amp pulses.
Yeah, I did not know it's that high at all.
Well, I'm just saying that impedance with this machine is everything.
Well, 70 something with this wire as it is.
Right,
It's
70
already
something with multiple connections and over 1.5 feet on both legs of number 12. And if I shorten that to say, 12 inches of number 4 direct without going through meters and everything else, it'd be way more. Way more.
No, we get amazing results, and this is not optimized.
Right.
I mean, I have 0 gauge wire in my car going from my battery
Zero
to
gauge,
the
right.
body.
There
and
you go.
0 gauge, and
Made a big difference.
made a huge difference.
Yeah.
Everything runs smoother.
Right.
Um,
So again,
I'll keep that in mind.
yeah, just, the clip leads are cool. It gives you an idea that, that is the circuit, okay? But if you want to see the benefits of all this high frequency radiant energy quality and electricity, then give it an open its throat. Give it a low resistance path and watch what it does.
poured it out.
Yeah, right. Let it breathe.
Because it really is about the back pressures. I mean, you put your foot over the tailpipe on your car and you'll stall the engine out. This is no different.
Yeah, that's an excellent analogy, actually.
Well, on that same kind of note, I did put together a capacitor discharge circuit like in page 47 of the intermediate book.
Yeah.
And what I'm wondering is what's the most straightforward way to make all the timing and the switching without having an oscilloscope. I mean, I would have to take it to, I'm in school right now, so I would have to take it to our computer labs or electronics labs. I don't have one at home, but I'm kind of having a hard time I have a meter across the battery, the discharge is going to.
Yeah, you got to be able to see. Yeah, the bottom line is that there's no real way of tuning up a circuit like that without seeing what it is. So even if you've got a laptop, you can go on eBay and buy a little software-based oscilloscope program that you can just plug into a USB port on your
I could look up that.
Yeah, for $30. I mean, there's no excuse for not having an oscilloscope anymore these days. It's not like you need to, $5,000 for Tektronix or something. So yeah, you've got to be able to see this stuff to do the science right.
And what should I look for exactly?
Just what you're looking for is the on-off time. In other words, when you can see that the cap is empty, it's time to turn the thing, to the charge mode again. It's just, in other words, the on time does not have to be very long. I mean, the on time meaning the discharge time. The discharge time can be 5% and the charge time can be 95%. But if you don't know where those settings are on the dial, then you don't know what you're doing.
Is it also different depending upon what battery you have hooked up?
Absolutely, and the gauge wire and everything else, because all of those things have to do with how quickly that cap is going to empty. You try and empty that across clip leads, and it's not going to empty very fast. You do that across 4 gauge, it's going to empty now.
Power battery on it, and the voltage across the caps just kept going up. I put it on a 12-volt car battery, lead acid, and then it kind of remained in that 16 or so voltage range. I can't really refine it like I need to at this point. So scope.
Yeah.
But
Yeah, don't try and do these experiments blind. Okay, if you want to learn it, don't forget all these books and these Designs are teaching tools. Okay, you're never going to build a machine that runs your house from these designs. That's not what their purpose is. The purpose of this stuff is to teach you the science that electricity and mechanics and all these things will behave this way if you follow the right rules. And that's going to lead to more robust industrial designs that are going to be economically useful to us. But right now we're just trying to teach ourselves the science. Okay.
yeah.
Great. Thanks for calling in.
Okay, let's see. Somebody else has a question. The last 3 digits of your phone number is 448. You should be unmuted.
Hi, yeah, this is Branch Gordon from Indianapolis.
Hey, Branch. Thanks for calling.
Thanks for, thank you. I had 2 questions, if that's okay.
Sure.
Is there an easy way or a circuit that I could find to auto switch the batteries from the front to the back, just in a continuous loop so you wouldn't have to manually do that?
Well, that's been the kind of the holy grail. The only circuit I ever saw that was designed to do that was in a test machine that was. You can see the picture of it. It's called the Solar Kick on the Energetics site. That machine was built in 2005 and put in the field and done a lot of testing. And it switched 2 big battery banks between running the house and being charged by a solar system. And but other than that, and that had what's called a latching relay. In other words, one short, sharp impulse to the relay would just throw it to the B position without having to use any more electricity. So, and then you could just push, and then one impulse would switch it back to A, and so on. So it didn't take a lot of energy to hold in one position. And so that's the kind of relay you're looking for. It's called a latching relay, and you probably want these things to be 100 amp minimum. Here's the problem with these systems, and why we have shied away from trying to put out a design for them. Okay. These systems are very impedance dependent, okay? And the fastest way to blow up your machine is to disconnect the output from a load, for one millisecond. That's the wrong time, okay?
Boom.
Boom! Everything blows up, okay? And so these mechanical switching arrangements are slow. And so what we were finding is that the trick wasn't coming up with a timer that was that would count out 12 hours and put out one impulse, and count out 12 more hours and put out one impulse. That's not hard. You can do that with a 555 timer and some very large resistors. So that's not a problem, okay? The problem is switching this thing in a way that doesn't blow up the machine.
Right.
Okay? So that's why we've shied away from trying to put out information on this so that people don't blame us for blowing up their machine. Okay? So right now, since this is in other words, this information is designed as a teaching tool. Okay? You're talking about something to run this thing seamlessly in the background is an industrial design. Has nothing to do with learning how to do it. And that's why we haven't put anything out on it. Okay?
Okay.
So if you just bear with it or do your own research and come up with something, no problem. But I don't think there's anything in any of the threads that shows a solution to this, because it's a little trickier. It's a little trickier than it seems. So simple. Oh, well, I just need a switch to do this. The problem is the environment. The environment is that you've got a very high speed machine and something that's incredibly sensitive to being unloaded at the wrong moment.
Yeah, the output has to go somewhere.
Has to go somewhere, or everything just blows sky high.
Yeah.
And no forgiving. You only have to miss one event, and every transistor blows.
And when you see that type of explosion, you know the electricity there really is a gas.
Yeah, because basically what happens, these things aren't, the transistors aren't melting. Big chunks of plastic get blown across the room. It's a pressure explosion.
Yep.
And it happens
So,
so fast. When we stopped building, the big machines don't even have neon lights on across the junctions. The reason is that when you get the impedance of the system down, the transistor will explode before the neon gas can light. It's that fast. Yeah, we laughed our way through a lot of transistors learning that.
so if you have more than one battery on the back end, and you're manually moving them yourself, are you saying that you actually need to turn off the machine, and so the wheel is still turning, and do the battery swap and then turn it back on?
Yeah, turn the front off.
Some of that inertia.
Right. Turn the front off. In other words, if you set up, so let's say you've got 6 batteries. You've got 5 on the back and 1 on the front. Okay? And we're going to leave 4 on the back all the time. So those 4 never come off the back. And we're just going to take A and B and switch them, front to back, and leave C, D, E, F on the back. Okay?
Right.
And so all you have to do is set up an arrangement to have where A and B can be either on the front or the back of the machine. Okay? And so the where everything else is on the back. Okay? And so the method of switching is you turn off the front so there's nothing coming out. Then you turn off the back. Okay? Then you turn the one that was on the front and connect that to the back. And then you take the one that was on the back and you put that on the front. And then the machine picks up where it left off with the batteries switched. Okay? But there's 4 steps there, and if you don't do it that way, something blows up.
Okay.
Okay? So, and that's part of the trick. Okay?
Okay.
So that the back always has to be connected first. We had a big sign on that 10 coil machine, and because it was so funny. It said, "Always connect the output first." Okay? And when we first built that machine, we had an amp meter on the front and an amp meter on the back, and the amp meter was just a super low resistance shunt, looking at a meter. Okay? And every time we turned that thing on, all the transistors blew up. We did that 4 times, and then I came to work one morning and John said, "Get that amp meter off the back." The machine could not handle putting the output through a 0.05 ohm resistor shunt. That much impedance forced the transistors to explode.
It's potato in the tailpipe.
Potato in the tailpipe. 0.05 of an ohm.
Wow.
You have no idea. Everything else was 2-aught gauge, okay? as big. The multi-strand was as big around as your thumb, and with insulation around it. And the battery it was driving into was 0.003 ohms. And we put a 0.05 of an ohm resistor in line, and it made every transistor blow up. That's all they would do, is just, you turn it on and it explodes on the first event. BAM!
Wow.
So this is not your mother's electricity, That's the,
Yeah.
this is different. And you got to build the machines to see it. One of the even the bicycle wheel machine that we use as the model for the beginner's handbook. Okay, when you run that machine with little 7 amp hour gel cells front and back, the thing works really sweet. Everything looks nice, and if you disconnect the back, all the neon lights light up. Really, and it gives a really sweet demonstration. Okay. If you replace those 7 amp hour gel cells with golf cart batteries,
Yeah.
225 amp hour, 12 volt, low impedance things, and you try and take that back off, all the transistors blow up.
Huh.
It will not do that sweet little thing where the neon lights light up. And all we've done is change the impedance of the front battery and the back battery. We didn't even change the
Yeah.
wire, we didn't change anything else.
Well, you've kind of answered my second question already, in that it was going to be, what do you foresee are some real-world applications for the amount of power coming off that generator coil? And just how far can you crank it down? I mean, if I had one, running here in my studio, obviously I don't think I could run, a vacuum cleaner or something from it. But they're talking like a couple lights, a laptop. Do you have any idea realistically of what that could be used for on that scale?
Again, the machines that you can build from these books are teaching tools. Okay?
Okay.
Learn about this type of electricity. Learn why John had a near zero drag generator in 1984 and didn't even care. I mean, my God, it's the Holy Grail. He didn't care. Why? Because the gains, when you understand what this other type of electricity is and what it can do, and especially what it can do in low impedance situations, you can see that the gains are much higher. And that's the message of the advanced
I
book.
have a solid machine charging golf cart batteries right now with pure radiant.
Right.
I mean, I understand that component. I think, I'm specifically just, on the side, interested in, I'd like to know if you guys have done any measurements on the amount of power coming off of that and what you can extract.
No, we haven't tried. Okay.
Okay.
Beyond all of the, the interest in this, we have never made a living building these machines. John has been running, an audio business and a battery charging, manufacturing business. And, and Aaron and I have been trying to figure out how to sell all this stuff for them and, and all this other stuff. Really, all of this information transfer on this technology has been our favorite hobby.
Yeah.
Okay? And we have done what we could with the resources that we had available to us. And we've gotten this far. Okay? the goal, there was never $1 attributed, brought into the situation to specifically answer that question. Well, what can we do as we move towards some sort of commercial application? No one ever gave us $1 to look at it. We spent all of our own money finding out everything that we've told you so far.
Okay. Okay. Makes sense.
It didn't make dollars, it made sense. That's the point. Okay?
Well, thank you for answering my questions, guys.
You're welcome.
I appreciate it.
No problem.
Okay, thank you.
Thank you.
And Branch, I'll get back to you on the forum about the question you had about the big batteries. I talked to John today.
Okay, awesome.
Okay.
Thanks, Aaron.
Sure, you're welcome.
Okay.
Okay, so let's see. Somebody has a question. Last 3 digits of your phone number is 057.
Hello, my name is Doug Zork in Philadelphia, Pennsylvania.
Thanks,
Doug.
Thanks, Doug.
Hi. I'm referring to the SG Advanced Handbook.
Okay.
And I particularly appreciated the comprehensiveness and some of the other systems that you covered here, and some of the information in the appendices. So my question is about John's cold electricity devices, I guess the Tesla switch, and the variations of the Cromray generator or
Yeah.
converter.
Yeah.
And if one were to want to experiment in this area, the first question is, are there any concerns with the type of radiant energy that can be generated either by the Tesla switch, I guess, which goes back to the Benitez patent of 1915,
Yes.
or the Cromray generator? Are there concerns about the effect on biology or on humans nearby?
In general, the effect is much more benign than standard electricity. But it is an what we'll call an unnatural form. Tesla was very clear about this, that the standard types of electricity that we use to power these machines does not appear in nature. It's an artificial construct that we can coax out of nature, but nature doesn't create these forms really the way they're used in the electrical systems. Okay, now the kind of cold electricity coming out of these SG machines primarily is voltage without current, or voltage with very, very, very little of what we'll call hot current. Okay, the energy from the 4-battery switch is really current without voltage, and this is discussed. Remarkably, there are a number of other people who have done work with this type of circuitry, and Aaron and I are still working on the possibility of putting out an entire publication on just that subject, because there's actually quite a bit of work that's been done, and other patents that have issued that talk specifically about this current without voltage in the system. And that's the energy that appears on the negative line between the two ground potential connections of the battery. Okay? And it's
Now,
okay.
oh, go ahead, sorry.
Well, I'm just saying that when you understand that all it takes to make a magnetic field are what's called ampere turns. How many amps through how many turns? Okay? And they want us to believe that somehow means watt turns, how many amps across how much voltage drop in the coil times how many turns is equal to the energy in the magnetic field. But that's not what it is. There doesn't have to be any voltage drop at all on the windings. And if you use one of these cold forms, what you find is that, as I said on page 94 of the advanced book, these cold forms of electricity really screw with the appearance of Ohm's law. And there doesn't have to be any, voltage gradient across these windings as long as there's actually no resistance. If the kind of energy that's moving through the wire doesn't see the wire as a resistance, then there doesn't have to be a voltage gradient across the wire for a current to flow. And current flow times turns equals magnetic field. That's all you need. So again, it takes a while to screw your head on with these things, and you've got to actually build the circuits and get them working right before you start seeing these impossible conditions appear right on your bench. The ones that we're told won't show up. Okay?
You mentioned earlier that increasing the gauge of the wire in the optimized SG offers a number of advantages by reducing the impedance mainly, I guess.
Correct, but we're dealing with the voltage with no current arrangements. In other words, what we're trying to do is make sure that the voltage is not dissipated across a resistance, because the pressure buildup, again, this goes back to the discussions in the intermediate book talking about the inertial properties of electricity. Okay? And what we don't...
It caught my eye that I think it's in connection with the Cromray converter that John was able to light 3 kilowatts of incandescent bulbs over a 30 gauge wire.
Correct.
And so whatever was flowing in that wire didn't need a 12 gauge or 8 gauge wire.
I agree. That's true. But what comes out of the Cromray is a completely different thing. It's just it's not the same as a standard inductor going into free fall. Because what you've got is you've got a sequence of inductors that are actually at the configured within a rotating radial distribution of inertia, which is called centrifugal force. The output coils are out at the end of a rapidly rotating iron bar, and the appearance of that voltage is not merely related to the collapse of the magnetic field. It's the collapse of the magnetic field within the inertial pressure of the centrifugal force. There's things going on in that generator that don't show up anywhere else.
Of electric force, electromotive force, which is centrifugal force acting on this type of electricity.
Absolutely. And they interact directly, and it changes the quality of the energy. If you don't build the machine, you don't see it.
Just one final question. Obviously, the Benitez 1915 patent worked without the application of solid-state devices like diodes and transistors. Has that device been replicated using the 1915 technology?
Well, see, this is where John learned this switching mode, from Ronald Brandt. And Ronald Brandt had an automobile running on this stuff using mechanical contactors. So yes, Ronald Brandt's large power systems ran on all mechanical contactors. So yes, that was done in the 80s.
Thank you very much.
Yep.
fascinating, and obviously there are many directions that we can go in.
Oh yeah, plenty to work with. Thank you so much for your interest and calling in.
And if you do want to look into some of the Benitez work in energeticforum.com, there's a couple threads in there dedicated to it. And one of the users, I'm not sure how his username is pronounced, Nile Rehab. I believe it's
Yeah.
Nilrehob.
Yeah.
And he has a couple YouTube videos on some experiments he's doing with some of these Benitez circuits. I think he's using more modern components and stuff. But if you look through some of the threads, I think he's posted some of the schematics and stuff that he's working on that goes back to that circuit. So
Yeah. In fact, I give the hot link in to the Benitez thread on page 95 of the advanced book.
Thanks, Aaron, and thanks, Peter.
You're welcome.
Okay.
Thanks for calling in.
okay, let's see. So it's about 7:23. How much time do you have? So
The night is young.
Okay,
I haven't
so
lost my voice yet.
okay, so I don't see that anybody has their hand raised. If you do want to ask a question, you might be muted out. You might not be. But if you hit 5,
Star 5.
actually 5 and the star sign, it'll flash a little symbol up here on my screen, and I can unmute you, and you can ask your question. So if you have a question, right now's the time.
What are these?
Okay, so nobody's raising their hand yet.
Oh,
Okay,
there's
somebody
one.
did. Okay, before we get to that, I just want to mention a couple things here. Just to kind of dispel some of the stuff. Because when we put out these videos, like the one where Peter and I are kind of doing a review on all 3 of the books, some of the history and our experience with the SG and everything, as you can imagine, I hear comments from all kinds of people from all over the world, good and bad, but which is, inevitable. But one thing I want to talk about, or just kind of briefly mention, is when you see these people, these skeptics who are really cynics, all they're trying to do is preserve their own worldview, or they're going to look at these meters and they're going to say, okay, well, there's only 30% recovery. These type of claims are completely false and are not based in reality whatsoever. For one, as Peter mentioned, the peak impulse coming from the caps, we're measuring at over 70 amps. Okay, and with the concept of having these inertial properties to the electricity that kind of keeps these things moving even if something is shut off, is that the concept of impulse power does something, whereas if you took the same amount of energy and used it over a longer period of time, it's the same energy, but you're not getting the same benefits. And just a super silly little example is if you got a little hammer and you walked up to a window and you tapped on it 10 times, you just expended X amount of energy over a certain period of time, but nothing happened to the window. And if you took all that energy that you dissipated over those 10 taps and you compressed them into one tap and you shattered the window, yeah, it is the same amount of energy, but when you increase the power by discharging it in a short period of time and you get a power increase, you can either have X amount of energy over a long period of time or X amount of energy in a short period of time. So energy at a low power and energy at a high power, they are not equal, they do not do the same thing, and when you have X amount of energy at a higher power level, you do get these sharp gradients where there are these inertial type electrical effects happening in the output battery that you can't account for just by looking at the meter. So what's happening in the battery is completely independent. It's related, but it's independent from what you're actually measuring on the meter, and that's why you can't really measure what's going on. And for these people to make these claims that you're only getting maybe 30% recovery, completely false. The real honest test is after the battery is charged, you actually have to put a load on it, draw it down to actually see what you're able to get out of it. Because if you're not doing that, and if you're just going by a meter, you're not even really measuring what's in the battery, because that's not going to tell you.
Yeah, the meters are showing some sort of average event again, and they're not showing the impulse event, and they're not showing what the inertial properties of the electricity that are released by the pulse methodologies, and
Right.
what those are doing at the molecular level of the battery.
Mm-hmm.
That's what the meter will not indicate.
Yeah, it can't.
Yeah, it can't. It doesn't know how. It's not designed to indicate those things. And so, yeah, Aaron's completely right about
Yeah.
that. So you have to build the machine and run it to see what it does.
Yeah.
The meters are interesting indicators, but they're not telling you the whole story.
Right. So you have to actually take the output battery when it's charged, put a load on it, like a so-called C20 load, or C20 draw it down back to where it was before you started charging it, and that's going to tell you how many joule seconds or watt seconds you actually got out of it, and you can compare that to what left the input battery. If you don't do that, and you see these people talking about, you're only recovering 30%, that's a sure sign that this person has absolutely no idea what they're talking about, and they've never even built the machine and done the tests.
Yeah, that's the most important
So-
thing, that you're not talking to somebody who's actually built the machine and run the tests. You're just talking to somebody who is parroting what they hope remains
Right.
true.
Right. Yeah, and these other things about the, the wheel is obviously doing mechanical work, and so there's videos online that we took an excerpt out of one of Peter's videos showing you how to actually put a little dyno wheel on here with a 12-inch circumference, put a leather strap on it, use the spring scales, and you can actually measure what the mechanical work is. And but no matter how you load the wheel, the input to output ratios are pretty much going to stay the same no matter what. So whether you load the wheel with a with a serious load on there, you just let it spin, the input output ratios are always going to pretty much be about the same. And so that's not going to change. But anyway, I just wanted to address those because I'm seeing these posts come onto YouTube and these other places, and I'm not going to name, some of these people. They kind of been a thorn in quite a few people's side for a long time, but they have absolutely no idea what they're talking about. It's complete misinformation. And so anyway, that's all I wanted to cover about that.
Okay.
So let's see. Somebody has their hand raised. I've just unmuted. The last 3 digits of your phone number is 888.
Hello?
Yeah.
Yeah.
Oh, hi fellas. Wasn't sure it was on or not.
Okay.
Barry here from Ontario, Canada.
Hey,
Kudos to you guys. I mean, the amount of effort you fellas have put into this is just for the benefit of all of those out here, like myself, that are building these things. It's been an inspiration to read I have the trilogy, all 3 books, and it's an amazing amount of effort you put into it. One thing I wanted to address and get both your feelings on it was the use of flywheels. The SG unit, the 26-inch wheel that I built, the most I was able to get out of it initially was 178 RPM. And one mistake I made was I did 2 things at the same time. I wish I had just done one at a time. The first thing was I weighted the wheel with automobile weights, okay? They were 3-ounce weights, 12 on each side of the wheel, which brings it to 72 extra ounces of flywheel effect. The other thing was I made an adjustable potentiometer trigger circuit. And the combination of the 2, and I don't know which one had the more effective arrangement, but the combination of the 2 brought the RPM level up to 311 RPM just with those 2 changes. And I just wondered if you would address the situation with weights and the flywheeling effect with the SG. Now that we're getting into having an outboard generator coil, I know Don has said it's not a generator, but we're sort of branching into that aspect of the machine with adding the generator coil. And I'm just wondering, what are your thoughts about having the wheel weights, and is this something you might consider on your display model?
One, I'm really glad you ran those experiments and were able to show yourself, these things. The reason you were able to get the speed up was probably because of the variable resistor and your ability to trim the trigger. But the extra weights on the wheel would give you another storage system, which is called stored momentum. So the machine has a number of the machine has a number of storage systems, and I was talking about that in relationship to John's original Energizer in the advanced book. Okay, that it had a method of storing momentum in the flywheel, and it had a method of storing electrical output in the capacitor before it was discharged. And these two storage mechanisms are very important for the overall economy of the machine, and how to get the machine into the window where it is putting out the most and drawing the least. Okay, and so the faster you run your Energizer, once you get it up into single triggering mode, what you can do is it may take a more trigger to get it up to a certain speed, but once it's there, you can back the trigger off with your adjustable by actually adding more resistance without losing any speed. This is
exactly. That's exactly what I've seen too, Peter.
Exactly. Okay, and that is one of the cute tricks. Okay, and especially
the carryover effect with the flywheel.
Right. See, and
Once you get it up to speed.
That and
it doesn't require quite as much energy then.
To keep it there. Right. And that's what the extra weights also help you do that, because the stored momentum allows you to warm up the bearings and just get everything up to that speed, and speed is something that's going to allow your generator coil to put out more. You see,
right.
So as you can
now,
get.
I'm running 24 magnets, 24 of the C8 magnets on this, so I'm getting at 311 RPMs, a little over 7,000 hits per minute.
Right.
Your unit that you've got turning up at 365 RPM, which I very much was jealous when I saw how fine-tuned you have that display unit and how well it's working. But you have 18 magnets on it too, so I have more weight because of the flywheel weights that I put on, but I have more weight because of the extra magnets. And in general, as you mentioned, the more magnets you have within a range, it's going to be running a little bit slower.
Right.
But the net effect, over the space of a 1 minute interval, I'm getting actually more hits per minute.
Correct.
Than even your 365 RPM with the 18 magnets. So I guess it kind of balances out in some in that respect.
What it shows is that there's no magic formula for this. Okay? In other words, the idea is whatever arrangement you pick, you're still looking for this minimum input, maximum output, maximum speed.
Right.
That's the window you're looking for. And we found something that worked so well on so little trigger, we couldn't even get it up to that speed at that trigger level. We had to actually put in this trigger shift thing to give it more trigger to get it up to the speed.
It's always so interesting when you see a unit that you built from absolute scratch,
right?
And comparing it with the experts like yourselves that have been doing this for so many years, and it behaved exactly the same way. As you say, when you turn it off and you restart the machine and you have your rheostat trimmed to where it was when it was running previously to a maximum, you can't get it there the next time unless you boost it. You bridge across the rheostat and give it the full boost into the transistors, and then it goes into overdrive and goes up to full RPM, and then when you release the boost, as you say, it seems to maintain that speed then.
Yep. And see, that goes back to the chapter in the advanced book about how these things produce torque in relationship to speed. The torque and speed relationship is linear, okay? Which means the faster it goes, the more torque it produces. And so once you get up there, the torque production is higher even though the current draw is lower.
Exactly.
And
my Syncor dual trace oscilloscope, when I was running initially, when I first got it built in August, was running, as I say, about 178 RPMs. I was looking at double H waves.
Correct. Yeah, it was double triggering at that speed.
I balanced it, and then I added the trigger circuit that I could fine tune, and it went all the way to 311 RPM. Around the 220 RPM seemed to be the spot where it kind of developed a mind of its own and seemed to go into like almost overdrive. And that is the exact spot when I was viewing the scope where it went from a wave to a single H wave.
Right, it's what
And
double,
that's why
double,
it just seems to just fire up to full tilt.
right, you know, it's where the thing shifts from double triggering. In other words, what's happening is that as the magnet approaches, it's moving slow enough so that the Lenz law controlled rise time of the coil comes up to the point where the trigger shuts off. It discharges, and then it has time to fully charge and do it twice before the magnet comes into alignment with the core. This is called double triggering. Okay? As soon as it gets up to
And
a
you
certain...
don't have the beneficial effect when you're in double triggering mode. It doesn't have the same sweet spot of output that it does when it goes into that single trigger mode.
Correct. You've got to be in single triggering per, in other words, one on-off event as the magnet approaches and leaves. Correct. That's where it's going to run the best. That's where it's going to run the fastest and the highest amount of
I
torque.
thought you made some amazing improvements. And as you said, Peter, in the video that I watched that you and Aaron did, you know, all those little things were cumulative.
Yep.
I noticed where you got away from the shaft extensions and went to a solid shaft through the unit and put the output bearings on. So you got away from virtually all the wobble.
Yep.
And by fine-tuning the spokes, you obviously got a very truly running wheel there. You mentioned in the video also about the possibility, I think, of the like a polycarbonate wheel that's made in a mold. Do you feel there to be less manufacturing error because it's made in a single piece mold as opposed to using the steel wheel?
Yeah, it'll run truer. The first big 10 coil machine was a polycarbonate wheel, and other people we talked to, that one was a bicycle wheel that we bought, directly for that purpose. And we've also talked to some another friend of ours who has used a polycarbonate wheel that was specifically made for a wheelchair, which also runs true and is lightweight and runs very true. So again, there's a number of things that you buy in the aftermarket as replacement parts that work really well as bases for building wheels this size. So.
Well, fellas, I don't want to take up any more of your time. I know you wanted to try and keep it to an hour and a half. We're over that already. I do want to thank both of you for all your effort. And I would certainly have to say this stuff does work. But people who haven't built a machine shouldn't be commenting. I mean, you really have to do it to be able to see some of the very unique factors of this cold electricity. And it behaves totally different than what you would expect. Even I've been involved in electronics for all my life. This is some pretty amazing stuff, and this particular project, I'm retired now, but this particular project has actually taken over my life, I think. I just got so engrossed in it. It's absolutely fascinating, and I wanted to have a note of thank you to Mr. John Bedini for making all of this possible for any of us to be doing any of this as well. So he may be the closest thing to a Nikola Tesla we have on the planet right now.
I wouldn't argue that. I would not argue that. So thank you so much. Thank you so much. I mean, yeah,
Thank you,
both Aaron and I.
all the best, and to everybody else out there too. Have a good one.
All right, thank you so much.
Let's see. Let me make sure I unmute. Okay, there, you're unmuted. Okay.
You should be there.
Hello?
Yep.
Yeah, go for it. Hello?
This is Josh Redder from Bismarck, North Dakota. And I just have a question about, you guys commented earlier tonight about the like gel cell, like SLA type batteries.
Yep.
I built a solid state, I guess you could call it radiant charger, over the summer, and I've been rejuvenating a few of my batteries with that thing. And I was following the procedures off of Peter's rejuvenation presentation, I guess, that I purchased back in March.
Yep.
And I saw the most of the effects, but what I noticed over the summer is I would top the batteries, and then I would drive the vehicles that they were in on, the same batteries didn't like stay rejuvenated. Like they definitely snapped back to life after a few charge and discharge cycles. But as I kept using the charger on them throughout, by the end of the summer, they just hardly didn't do anything. Are those batteries? Should I ditch the batteries and try something else, or what's your opinion?
Yeah, the battery's telling you the truth. You know, by using the radiant energy on those batteries repeatedly, you've slowly dried out the electrolyte, and that's exactly why why we say don't use them. The gel
Okay.
type. Yeah.
A few of them, I popped them open and added a little bit of distilled water, like to them. I know I don't think you're supposed to do that, but I tried it anyway, just because that's what the majority of my experiments have been.
Right.
And then I would, wiggle the batteries around, tip them around, so the water would moisten up the foam or whatever that's in between the plates inside the batteries, and that seemed to help like a little bit, but that was only temporary for maybe a few more charge and discharge cycles. They're the batteries, because now I have a set that I bought brand new a few years ago, and they came pretty sulfated, and so then they snapped back, and now they're basically worse than they were to start with. Are they done for good?
I think so. Yeah, the gel battery, like I've said, repeatedly, the gel battery is the perfect solution for the battery industry. They can give you something, that they say, won't spill. It's a non-spillable battery, but it's also a battery that cannot be made to run indefinitely, because the electrolyte, once it dries out, the only thing you can do is recycle it. You can't rejuvenate it indefinitely like a liquid cell. Yeah.
Okay. I have one more question. Is that okay, or are we short on time?
No, go for it.
Okay. It's another question about your comment about the lithium iron phosphate batteries. I watched a few of your other posts that you commented how those have to go to 14.8 for like an equivalent 12-volt battery. Can those be radiantly charged, or do those need to stay with the hot current?
No, that can be radiantly charged. We've talked to people who've radiantly charged them with, John has always felt that you need to be careful with those batteries. But again, the bigger the battery, the less careful you have to be. And the reason we haven't really, this is the first time we've even mentioned it in any of our materials, because we by the time we actually say something, we like to know we're right. So you're getting information that is, for the most part, it's been tested, 25 times to make sure that we know what we're talking about. This is new information about the lithium iron phosphate batteries. It's a new battery. It's a new information. We have very positive reports about these things, but they have their own limitations. They're very unforgiving about being over-voltaged. That's one of their weaknesses. You try and put 16 volts on these things, and you can damage them so that they stop charging. Okay, and so it's really important. It's important that if you do radiant charging on these things, that you're using a fairly large lithium iron phosphate battery. The little kind that will fit in your hand is not the right battery to put on your machine. Okay, you can get away with that kind of thing with the lead, the lead acid types. The little sealed 7 amp hour, 4 amp hour. It'll run the machines and charge, but don't try that with a lithium iron phosphate battery, because you'll blow it. Okay, so
So the bigger the lithium iron phosphate cells, probably the better for radiant charging.
Correct. Well, the more tolerant they'll be, because you are throwing voltages at it that are higher than they want.
Right.
Okay, and so anytime you know that you're you're providing a set of circumstances which is above their standard specification. To err on the side of caution is better. That's an expensive battery to learn that you blew it.
Yeah, right.
Okay?
Right, yeah.
Okay? But just realize that, the amount of money that has been spent on batteries that couldn't be rejuvenated anymore, and how many transistors have been bought that were blown smithereens, and all of these things, all of this stuff has come out of the fact that, millions of dollars have been spent to bring this information to you, okay? And there isn't an engineer out there, who doesn't have at least a coffee can full of blown transistors. If you think you're going to build all this stuff in an experimental setup and not destroy some of your equipment, then you don't know what being an experimental engineer looks like. Okay?
Right.
So that's what's to be expected. You're going to find out what the limitations of the circuits are. You're going to find out what the limitations of the batteries are. You're going to find out all this stuff by doing it and by exceeding those limitations and blowing shit up. That's the fun part. You've got to let the smoke out once in a while.
Hey, I do want to mention. Hey, let's take a second and mention about the equalization circuits on the lithium iron phosphates.
Okay, yeah. Lithium iron phosphate batteries equalize in a different way than lead acid batteries. In a lead acid battery, what you do is you'd find the cells that are lower and you charge them up to where the rest of them are, if you can, okay? And that's what's called equalization. In a lithium iron phosphate battery, they come with a special circuit, and what you do is, if you've got a cell,
sometimes.
yeah, sometimes
a lot
the
of
bigger ones come with a special set of circuits that, and the way you equalize a lithium iron phosphate battery, the bigger ones, is that you discharge the cells that are higher down to the ones that are lower, which is the exact opposite process, and
Right.
and then you charge the whole thing back up. So there's a whole bunch of differences. It's really a different animal, the lithium iron phosphate battery, but it's worth learning about. It's worth experimenting with.
Steady voltage all the way across
Yeah.
until it drops off the cliff.
Yeah, it's a constant voltage battery as opposed to a constant current battery. Lead acid batteries drop in voltage while the current stays. While the lithium iron, the voltage stays very constant, and then when you get to the end, it just falls off a cliff. So I mean, they're very different, and but it's worth looking at, especially in regards to this technology that we're talking about. So thanks a lot for all your questions.
Yeah, you're very welcome. I was just gonna try a few experiments on the one I purchased a 24 volt, 20 amp hour lithium iron phosphate, and they have the BMS or the equalization. Well, I suppose it's both in there because it's definitely shut me down when I've tried to draw too much out of it. I suppose that would have to be like bypassed if I wanted to try radiant charging it.
Well, just be careful. You know what it cost you, and
Right, yes.
so I mean, the reason we say that you can't use Tesla chargers on a lithium ion battery is because they have inline fuses for the exact same reason. They're
Right.
very intolerant of being given over current situations, and if you bypass that, you bought the battery. 15 minutes of the wrong conditions can trash it.
Right, yep.
So be careful. That's why we tell people to learn this technology on lead acid batteries. Because
Yep.
you can get those things pretty cheap.
Mm-hmm.
Yeah. Very good. Thanks so much.
Yep, thank you very much. Thank you, guys.
Okay. Take care.
It's Ken Rumble in Carcross, Yukon calling.
Hey.
Hi, Ken.
Gentlemen,
Can you speak up a little bit, just so you get picked up by the camera a little bit better?
Yes, it's Ken Romo in Carcross, Yukon, Canada calling.
Great, thank you, Ken.
Good evening to you, gentlemen.
Yeah, same to you. Thank you.
And thank you so much for doing this. I'm been involved in this experimental game for a bit here now. Been to all the conferences, and I think I have 5 wheels that I've built. I have one here with running as we speak with 21 magnets on it, one with 18 and one with 40.
Okay.
So the schooling goes on. There's an old adage that schooling ain't cheap, and I think it fits into this experiment we're doing for sure.
Yeah.
In the question I have, Peter and Aaron, is in number 37, I think it's energy from the vacuum. John shows his arrangement there, and he says he put a dual fan on to slow the speed down, but no one's ever said what speed that he was trying to attain there, and actually why. Can you elaborate on that?
Actually not. You know, the films that John does for Tony Craddock, you know, are you know, have a slightly different purpose than the books that we've written. Okay, so I don't know why John says some of those things. Okay, like 2 fans. Okay, whether he's trying to show that the machine is capable of doing, you know, a certain amount of mechanical work, or what. Okay, so that's a set of conditions that you're welcome to, you know, reproduce in your own experiments and see what it does. But exactly why John said that on that film, I don't know.
Okay. Because what I found is that it seems like we're after speed to get more impulses. That seems to be the objective.
That, yes, correct. Yeah, it works better on the big batteries, and it definitely works better. Speed is a critical factor, especially when you want to get your big low drag generator going.
I'm very jealous of your 365 RPM because I have not been able to obtain that myself at the various RPMs that I've been fooling with. It seems when you add the comparator to it, it slows the wheel down somewhat.
There's all kinds of different things that change the speed of the wheel, and the load impedance is one of them. This is another thing that most engineers just cannot comprehend why that's all happening that way.
Right.
But I think what gauge wire are you using?
I'm actually using at least number 12 or bigger.
Okay.
And my cables, I have a common bar that I go to with everything, and for both, you know, for all 4 posts, you might say, and they're made of copper pipe flattened out and
Okay.
into an angle so that you can bolt stuff to it.
Good. Yeah. So your impedance, your wiring impedances are really low.
I think they will be. I got, you know, large battery cables going from those bars to the battery, so it's.
Don't forget, every time you change metals, you're introducing a resistance as well. So if you're in copper, try and go copper to copper to copper, or even if you have to just use clamps to clamp a copper wire to a copper bar, and make sure that also that you use a sandpaper or an emery cloth or something like that to get the oxides off, and and then once you've got your mechanical compression contact there, spray that purple stuff, that is used in for automotive battery terminals to keep the oxygen away.
Dielectric grease.
Yeah, dielectric grease and all that kind of stuff. Every one of those things, changes the benefits of it. So, clean unoxidized copper to copper is the best. And every time you change a metal, you've created a dielectric junction that has a voltage gradient across it, and that's either gonna work against you.
Each of those terminals, those squeeze-on terminals that we put on them, they may have an effect as well then if they're not.
Absolutely. Yeah, we try not to use them.
Okay.
I mean, if you're getting serious about lowering the impedance of the system, get rid of all of that, tinned, connector lugs and things, all that compression stuff that goes copper to tin to some screw down thing to another piece of tin to then back to copper and all that kind. Every time you do that, it looks pretty, but you're adding impedance on impedance on impedance.
So there's a purpose then on Tom's board then of having the little pin with the spot to put the coil wire into and tighten it down.
Yep. All these things. You just find out by doing. But everything you can do every single time you avoid adding 1/100th of an ohm of resistance multiple times, the machine works better.
Okay, well that was what I was wondering about.
Very good.
And,
Thank you so much.
again, thank you guys so much, and a special thanks to Mr. Bedini for setting us on this journey we're on.
Yeah.
A little like the fellow from Ontario, I'm retired and it's taken over my life, I think.
Yeah. You're in the same disease mode that we are.
We forgot to put a disclaimer in the book about that.
Yeah, right. We didn't ever disclaim that it wouldn't cause an infection. Exactly.
I think it's full blown. No.
Yeah. We all have this terminal disease that never goes away. So yeah.
Again, thank you so much.
We've been going for 2 hours, and I think we're gonna wrap it up. Yeah.
Yeah, if you have general support questions and that kind of stuff on this, if you're on this call, I'd really recommend joining EnergyScienceForum.com.
Yep.
That is pretty much the official SG thread where all the Yahoo groups and that kind of stuff got compiled there. John, looks over the threads himself. He doesn't have a whole lot of time to post because he's so busy with his company, but
Tom Childs is there all the time.
yeah, Tom
helping.
Childs and a
yeah.
handful of other, really knowledgeable people
Yeah.
who can probably answer the questions too. And if you look through there, you'll probably, have a lot of your questions answered. There's a lot of builders in there sharing their experiments. And if you've been building stuff, I really encourage you to, post some pictures and videos in the forum and share it, share it with everybody and,
Yeah.
show where your builds are at. And if you are a beginner, just look in a beginner's book and just build a little roller skate wheel model. The old original, single power wire version. Probably for about $30 you can build one to make it work to at least kind of, learn the basic principles and stuff.
Yeah.
And at some other point we can probably, do another call at some other time to, answer more questions and everything. So do you have anything else you want to
No, just again, thank you, Aaron, for keeping all of this, communication going. John and I've worked, 30 and 40 years on this technology, but none of this would be happening if Aaron hadn't been putting together these forums and setting up all these mailing lists so that people can be informed. And all of this kind of stuff. I mean, it's been a gigantic effort, and it's taken all of us, to including everybody on the call and everybody who's bought the books and everything. I mean, we have all played, a role in this event of this information getting out. And so thank you for what you've been doing. Thank you for being interested. Thank you for taking that interest and turning it into action, and that's what's made it possible. So, we get thanked a lot, but the people thanking us also need to be thanked because if they hadn't jumped in and wanted this information, believe me, Aaron and I would have to go dig some other ditch. And it's been really a lot of fun learning about all this stuff. And
Purposeful.
yeah, and I mean, our job has become, not only to learn the technology from John, but to invent a language, to describe it to first ourselves so that we can understand it, and then to the rest of you so that it works better in your worldview. Listening to John talk about this stuff, I still am mostly lost. John understands this stuff at a level that is really beyond, and the language that he uses to describe this stuff is still in many ways beyond my understanding. And it's not because what he says is what he says is quantitatively different than what we say. He's using a different language, but that language developed out of his experiments and his watching what the machines do. And every one of us has to figure out how to explain it to ourselves. That's what we're trying to do, to develop a common language whereby we can talk to each other about what we are learning. But these machines have a lot to teach, and it's just been an amazing journey, and I feel privileged to have been a part of it up to this point. And definitely a special super thanks to Aaron for creating the mechanisms that allow all of this communication to happen.
Okay. Well, it's been a privilege for me to be part of such an incredible team. Over the years, seeing where it came from.
Yeah.
Walking into John's shop the first time back in 1999, and then, fast forward 15 years.
Yeah.
Here we are, and I never saw it, going this far.
Well, that's the whole point. This future, now, none of us dreamed of. We had no idea what could happen. We were always being just told no. Yeah. No doesn't create a very big future.
and if you are just beginning, it doesn't have to cost you a lot of money. When I started, the first one I built was that little pink roller skate wheel model. I went to a Goodwill store in town, and I bought a $2 pair of children's roller skates with pink wheels on it, and that was the rotor for my first SG. And I played with that for months and months and months, doing literally hundreds of all kinds of experiments on it. And so there's a lot you can learn even with a little low budget build like that.
Oh, yeah.
And and when I did it, I didn't even know the difference between a transistor or a diode or anything. I just got this part and that part and put it together the way the diagram showed, spun the wheel, and it ran on the first time, and I was hooked. And not having the background like that, if I would have had these books 15 years ago, I don't know, it would be anti-gravity UFO by now or so, I don't know, but
yeah.
So I think it's really fortunate for people to be able to walk into this from scratch and have this A to Z right here.
Yeah, to have gotten it this far is just it just feels like a huge amount of work. It's taken. John published the method on how to do this 30 years ago, and
he'll continue to innovate.
Yeah, but the point is that the book that showed how to build the first running energizers, the machines worked and nobody cared. That's what's so astonishing about this event. It's just like it took 30 years to for enough people to wake up and decide that this is important. Mm-hmm. That's how far John has been ahead of us, and he recognized it as important a very long time ago, and we're catching up, and we're just glad to be a part of it now. That's for sure. So, thank you all again for being on this call tonight, And we'll get recordings of this, and audio and video probably available. I don't know.
Yeah,
Aaron,
I'll try to put this on YouTube before the end of the week. Next few days I should have it on there. Then I'll send a link out to the same list that you found out about this call.
Yeah, so at least you'll be able to
So-
see us looking at a phone.
Right. I know you can't see us, but we can see you. No.
So thank you again for being here tonight, and
Okay.
good night.
Okay. Good night,
All right.
everybody. Thanks.
Thank you.
Conference unmuted.
Good night, everybody.
Good night.